Okay. So, who wants to volunteer for B for prize? Autumn.
Do you just want me to like say
Yep.
what I have? So I put the first one as 26.
Mm-hmm.
And then I like subtracted 1, so it was 25.
Mm-hmm.
And then 24. And then 23, 22, and then 21.
Awesome. And what did that end up to be?
165,000. Oh wait, million. 765,600.
Nice job. Everybody else get the same answer? Cool. So notice that just by saying you can't repeat stuff, it almost cut it in half, which is pretty impressive. Nice job, Autumn. Grab a prize. All right, who's got C? Nathan.
So the first one is missing, like, it cannot be 4 letters of the alphabet, the first
Mhm.
4. So it'd be 4 subtracted. So it'd be 22.
Mm-hmm.
And then the rest, it could be any letter and repeat, so it's all letters of the alphabet.
So all 26?
Yeah.
Nice. And then what'd you get?
261,390,272.
Again, knocked it down by almost 50,000 just by taking out 4 possibilities of just the first thing. Pretty surprising. Nice job, you two. All right, does everybody feel like they understand that? Great. All right, so there are 3 kinds of probability. One is called classical probability. This can be done with like a calculator and no experiment. Like this one. A, B, and C from the last problem, that's called classical probability. Next one's called empirical probability. And that one is where you use data from an experiment. Or just data you collected in a study somehow. An example of this would be like lightning strikes. How do we know how likely it is for you to get struck by lightning?
You saying that's
It's a very creepy way to say that, but I almost like it. Let's see. What are the chances you'll get struck by lightning? Anybody have an idea?
Probably like 1 or 2 people would actually do.
See, the chances probably are higher than how much it actually happens.
1 in 15,300. That's in your lifetime, though, that you would get struck by lightning, not in a certain storm.
Is that like per day?
No, it's like any time in your lifetime, 1 chance out of 15,300.
So right now.
Yeah, sure, right now or anytime. How do you think they got that number?
Go outside and count.
Yeah, literally, they just counted up how many people got hit by lightning every year. Then they looked at the data from like the last 40 years, and then they could estimate, okay, this is a regular person's chances. of being hit by lightning. Of course, there are some people that have way greater chances of being hit by lightning than others. For example, if you're the kind of person who, I don't know, chases tornadoes, I bet you have a better chance of being hit by lightning than somebody who stays inside during every single storm. So, you know, if you're the person who's working on power lines to get them up during a storm or after a storm, I bet there's a better chance you're getting hit by lightning, just because of your occupation. So empirical requires data. The last one is called subjective probability. Anybody have a guess for that one, based on the word subjective?
It's just kind of what?
It's an educated guess, usually educated. A good example of this is like the weather forecast. It wouldn't make sense to use previous data to predict the weather. Like, you can definitely notice patterns of storms and how things usually work, but you can't be like, okay, today's November 28th, so I looked at the last 30 November 28th, and I found out a whole bunch of them were snowy, so I assume that this one will be snowy. Last year's November 28th doesn't necessarily mean that this year's November 28th will follow the same pattern, right? Instead, meteorologists look at weather patterns, and then they make, in the end, an educated guess. So you know all those things that are like, it's an 80% chance that it'll snow today? That's somebody's educated guess based on an algorithm that we made up. Educated guess, subjective. Now, they could also be not educated. There are lots of people who would just make non-educated guess. I'm sure you've read some of them on the news, or in newspapers, or online, most likely. Give me an example of a really bad probability that it's obviously not true, that you feel like somebody could make up. Dogs, we need a probability, so we need like a percent or like a out of or something like that, numbers.
Like 90 out of 100 people get struck by lightning.
Sure, 90 out of 100 people get struck by lightning. We've had people all the time who are saying stuff like that. You're definitely going to get struck by lightning, for sure. I mean, 90 out of 100 people are struck by lightning. That's just made up. Okay, so people do make up stuff, that's for sure. All right, this next one is classical. This is something we can just figure out on our own. How comfortable are you guys with playing cards? Do you know how many are in a deck? 52. Everybody write 52 in a deck of playing cards. Autumn, Jessica, you play with regular cards often or no? So you know the 4 suits? The 4 kinds of cards in a deck?
So like spades, hearts.
Yep, okay, so we got spades. I don't know why I've already chosen to draw them, but here we are, me drawing them. So we got spades, and we got hearts, and we got clubs. What's the last one? Aces are a type of like heart or club or spade. Diamond. You sound so sad. Sure you don't need to go home?
Yeah, I asked my mom to stay home, and she was like, no.
Okay. In each suit, there is ace through, no, let's put it this way. Let's say in each suit, there's 2 through ace, which is 13 cards each.